In this video, I'm going to go over percentage composition calculations. This is relevant to National 5 chemistry. I'm going to go through the calculation, do an example, and then look at two past paper questions. To begin with, percentage composition is a representation of the amount of an element in a compound expressed as a percentage. This is done by mass, not moles. The first thing we need to do is figure out the chemical formula. However, if you're being asked to calculate percentage composition in an exam, then the correct formula will have already been given, so I'm going to skip that part. But make sure you know how to do it. Okay, so now we know or have been given the correct chemical formula. Now we need to calculate the gram formula mass, GFM, of the compound using the relative atomic masses for the elements on page 7 of the National 5 data book. Okay, so let's do an example. So how about sodium chloride? Now, chemical formula is NaCl. So to calculate the gram formula mass, we have one chlorine atom weighing 35.5 grams equals 35.5. We have one sodium weighing 23, or with a mass of 23 grams. Okay, 23. So we add them together and we get 58.5 grams. Okay, now we have the gram formula mass. For the element we are interested in, we then need to calculate the total mass of element present in the compound. So if we want to know our percentage composition of chlorine in our solution, let's highlight that, chlorine, then we know that we only have one chlorine in our compound. So we would express this as the total mass of chlorine, which is 35.5, over 58.5. And we need to multiply this by 100%. And that gives us 60.7%. You need to show you're working for full marks, and this means the relationship. You need to show this relationship between the total mass of an element present over the GFM multiplied by 100. And also remember the units, in this case percentage. So let's do another example. So what about magnesium chloride? And the formula for this is MgCl2. So if you want to pause the video, you can have a go yourself and then play to see the answer. Okay, going ahead with the answer. So first of all, we need to get the GFM. So now we have 2 chlorine in our compound. So that is going to be 71. We have 1 magnesium, which has a relative atomic mass, 24.5. So our total GFM is 95.5 grams. Now, again, if we're interested in the chlorine, we need to make sure it's the total mass of chlorine present. So in this case, we need to include both those chlorines in our relation. So in this case, it will be 71 for 95.5 times 100%, and that is equal to 74.3%, making sure to include those units. Okay, so those are examples. So let's look at some past papers. So, and here we go. So in this case, this is from 2019, and this is part of the multiple choice. So we are already given the chemical formula, as well as the GFM in this case. and we are being asked for the percentage by mass of nitrogen and ammonium nitrate. So we don't actually even need to finish the calculation, but let's have a look at our examples. So first of all, well, let's look at C. So C has we're multiplying by 80 here. And we always multiply by 100, so we can get rid of C. That's not going to be it, because that's not how you make a percentage. Now, D, it looks like we've got our gram formula mass on top of the relation, which we don't want, so we can get rid of that as well. Now, we've got a choice then, A or B. Now, remember, we need the total mass of the element present in the compound, and we're being asked for the nitrogen. So nitrogen has a relative atomic mass of 14. Two of them would have 28. So our final answer is going to be B. That's what we're after. Okay, let's do another example. Where did I leave it? There we go. Okay, so this one is from the 2018 past paper. So this, we need to do our full calculation. Now, interested to know, you might have heard of iron pyrite, because it's known as fool's gold, and I've got a little bit here. So, you can see it's nice and lustrous and yellow, similar colour to gold, but absolutely no gold present. Alright, on with the question. So, in this case, we've been given the correct formula, but we need to calculate our gram formula mass. Now, so, if we write down the formula here, we have 2 sulfurs, each weighing, or each having a relative atomic mass of 32, and then we have 1 iron, which has a relative atomic mass of 56. Okay, so this is 64 plus 56. We end up with 120. Now, we're being asked to find the percentage of iron in our compound. So our expression is going to be 56 over 120 multiplied by 120.